Okay, so this is objective 3.2e, the last day of absolute values for this semester. Today we'll be solving double absolute value inequalities. So an absolute value on both sides. So we're going to start with a rule that's going to allow us to solve these problems. And the rule says this: if I have the absolute value of some number x, I can write an equivalent expression that will give me the same result, but will allow me to release the x from the absolute value without breaking any laws of math. I can say that the absolute value of x is the same as the square root of its square. They mean the same thing. Typically, we would use this rule when we were doing a complex number like the absolute value of 3 plus 4i. We would definitely use this rule, but we're not doing it. Let's prove that it's true. Let's say, for example, I have the absolute value of -2. Now, you all know what that means. The answer's 2, right? But when you have an x, you don't know what it is. So in order to release it, you've got to take some steps. So is it true that the absolute value of -2 is the same as the absolute value, or the square root of -2 squared? Yeah, that's 2 is equal to the square root of 4, and 2 is equal to 2. That's true, right? So what we're going to do is we're going to be replacing all of our absolute values with its replacement value that means exactly the same thing, but allows us to release the number from the absolute value. So what we do, step 1, is we're going to break the quantities out of the absolute value. Bars. We're going to break them out of 2. Because they're behind bars. See? 1, 2. Bars. Break them out. And by applying the rule that the absolute value of any number is the same as the square root of that number's square. This is a rule that we use when we have an unknown variable. Okay? Once we do that, we're going to end up in a situation that's not going to be friendly. So in order to avoid the situation, we're going to square both sides. And you'll ask me, Mrs. Frame, do we really have to do step 1? And I'm going to say yes. On the test and on the quiz you do. On your homework, you're going to do what you're going to do. You'll find out what I mean. After we square both sides, we're going to expand and simplify our new inequality, because we're rewriting it as a different inequality, no absolute values. We're creating quadratics. It's going to look messy, but don't freak out. After we expand and simplify, we're going to move the variable terms to the left, and we'll move the constant to the right, and we will solve. And I like to put the variable on the left, as you know, because I like to use the inequality sign as my indicator which direction do I go. Do I go negative infinity or positive infinity? So that's why I always like my x on the left. Then we'll write our solution in interval notation. All right, so that's the process that we'll go through. Probably want to put this on your little reminder sheet for tomorrow. Or maybe just a practice problem if you'd prefer that. So here we go. Problem 1. This should look really familiar to you. It looks like the bell work, but it's not. What's different? The inequality, yeah? This time the x is greater than the x plus 2. So could you make a determination or a prediction of what you think the answer is going to be to this one? What do you think? The opposite of what it was, right? Remember, it was from -1 to infinity? So negative infinity, -1. Let's see if it's true. So we're going to first release them in step 1 by replacing the absolute values. We're going to break them out of their absolute values by replacing them with the square roots of their squares. So remember, those are replaceable. Substitute. On the second term, the binomial, we're going to have to tack a little quantity around it when we square it. Because we don't know what x is, but we know it's 2 bigger than whatever x is. X is 2, it's 4. If x is 8, it's 10, whatever. Okay? Now, what do squares and square roots do to each other? Cancel each other out. And now you can see that we have broken out the x's. They're out. The absolute values are gone. Okay? So now what we have is we have a problem. We have a serious problem. What's going to happen? If I solve for x right now, what's going to happen? They're going to cancel out. And I'm going to be left with the statement 0 is greater than 2, which is false, which would indicate to me in the past that there's no solution, that there is no time when this is true. But guys, it's not the case. So I will remember back to the rules that I have mentioned to you before. Sometimes when you don't like an equation or an inequality in the form that it's given, you can change it, as long as you change all of them doing the same thing. I could say here and multiply both sides times 2, or multiply or divide them all by the same number. But the thing is, if I do that, I'll end up with 0 is greater than 2 when I solve it. So what we're going to do to help us to get to the actual answer, instead of multiplying both sides times something, we're going to square both sides. And as long as I do the same thing to both sides, I'm not changing it really, just making it look different. So we'll square. So we'll go x squared is greater than the quantity of x plus 2 squared. Which probably feels like a lot like, why did we do that whole first step? Right? Why didn't we just go from here to here? Well, because that's skipping a step and it's not a true statement. This does not replace this. It doesn't. Okay? So now we move on to step 3 where we expand. Well, on the left, there's nothing to expand, but on the right, what we want to do is multiply x plus 2 times itself. We want to square it. So we're expanding. On the left, there's nothing to expand. On the right, we're going to distribute. So we get x squared plus 2x plus 2x plus 4. And of course, if you remember how to square a binomial in your head, I would love for you to do that. But for your notes, we'll just take every step without skipping anything. Now we simplify. We expanded. Now we simplify. So x squared plus 4x plus 4. Do you agree? Combining your like terms. Okay, so that's step 3. Step 4 is to bring all of the variable terms to the left and move the constant term to the right. So would you agree that I'll be subtracting the x squared and subtracting the 4x to move them to that side of the equation? So I will really have x squared minus x squared, right? And then minus 4x is greater than 4. That looks messy. Let me draw that again. I'm just going to rewrite this. So I'm going to subtract x squared, and I'm going to subtract 4x so that I can cancel them out. So over here, thank goodness, the squareds cancel out. So now we don't have to worry about factoring or using our quadratic formula. We end up with a negative 4x is greater than 4. Starting to feel pretty good about this. When we divide by negative, of course, we remember to reverse our inequality, and x is less than negative 1, which was our prediction, if you remember. So I'm going to graph that. Since my x is in front, I'll use my arrow to determine that I want to go to negative infinity. And my solution is from negative infinity to negative 1. And that's my solution. And of course you can plug in values to make sure that it's true and that you haven't made any mistakes. But that's the process that we're going to go through. Problem 2. You need me to go back? Okay, problem 2. So step 1, break them out, right? So if I want to break them out of an absolute value, I have to replace them with something that's actually the same. And that would be the square root of the square of 3x plus 3 is greater than or equal to the square root of the square, 3x minus 2. Okay? So we're following rules. We're replacing absolute value statements with an equivalent statement that's true. And now we can apply the square roots and squares cancel each other out, leaving us with 3x plus 3 is greater than or equal to 3x minus 2. So the absolute values, without skipping any steps, without breaking any rules, we have released the absolute value. Step 2. Again, you'll find what's going to happen with my x's. They're going to cancel out. They're going to zero out. And I'm going to be left this time with a true statement. 3 is greater than negative 2, which typically would indicate to me that all of the numbers in the number line are true. But I think there's a lot of negative numbers that won't work here. A lot. So, in order to avoid that issue, let's square both sides. So remember, as long as we change both sides the same way, we will still have an equivalent inequality. And this will allow us to get to where we want to go. So we shall expand in step 3. 3x plus 3 times itself is greater than or equal to 3x minus 2 times itself. And then we'll distribute so that we can do that multiplication, right? I'm just going to do that one indicator just to be a reminder. I'm not going to do it all the time. So that gives us 9x squared plus 9x plus 9x plus 9, that's a lot of 9's, is greater than or equal to another set of 9x squareds. This time I have a minus 6x on minus 6x, and the negative 2 times negative 2 is positive 4. So expand it, now simplify. We have 9x squared plus 18x plus 9 is greater than or equal to 9x squared minus 12x plus 4. So we're on to step 4. And in step 4, we want to bring variable terms to the left, constant to the right. So I'll be subtracting 9x squared and adding 12x to both sides. Oh, okay, thank you. And then, since I'm bringing the x's to the left, I'll take this 9, subtract it, and put it on the right, so constant's on the right. I'm going to simplify up here. So you know your 9x squareds are going to cancel out. So that's a relief because now you don't have to work with the quadratic. So it looks like I have 30x is greater than or equal to negative 5. Correct? Okay, then all we have left to do is divide by 30, and of course we should probably simplify that fraction to negative 1/6. So we have x is greater than. So since our x is in the front position again, we can use that arrow to indicate we're going to positive infinity. So we want an opening bracket, not a closing bracket, at negative 1/6. And our solution, inclusive, negative 1/6 to infinity. And this is the process that you have to follow. And like I said, it's not really intuitive. It's not something that you can just kind of guess your way through. You're going to have to follow the steps and practice. You are going to do problems 71 through 74. The last 4 problems on yesterday's assignment. That's it. The last 4 problems on that worksheet